everybody and welcome back to my channel. So today we will be discussing this question which is from Geeks for Geeks, which says that you are given an array of size n minus 1 and you know that the numbers are within the array range from 1 to n, and hence we have to find the missing number, which means that suppose the n given to us is 8, which means my array will have numbers within the range 1 to 8, and as we have only 7 numbers, so one number from this range is missing, and hence we have to find this number. Now, before starting with the videos, to all the people who watch my videos but they do not subscribe to my channel, so please don't do that and just subscribe to the channel. And also I upload short notes on my Instagram handle, so you can go over there and save all the notes from there. Okay, so we will be discussing all different ways using which we can do this particular question, and we will also be discussing the time and space complexity for the same. So the first method is, which is a very basic and very direct approach, that what we can do is that we know that the numbers are from 1 to n. So I'll just keep a variable I which will give me these numbers. Now suppose it will give me 1. I will traverse my whole array and I'll see if 1 is there or not. If 1 is there, then we are going to increment it. We'll make it 2. And if 1 is not there, so we'll just simply say, okay, so the missing number is 1. And we are going to iterate or this increment this I from 1 to n, so that we just find our required number. So this is a very not so good approach, because it takes time complexity of order of n square in worst case and average case, and in best case it takes time of order of n, and space is of order of 1. So the next approach that we can use is that what we can do is we can just sort the array. Now let me just take an example. Suppose we have array like this. Okay, so we have 1, 2, 3, 7 numbers and n is 8. Now what we can do is I can just sort this array. So we'll have 1, 2, 3, 5, 6, 7 and 8. So sorting takes n log n, and then we can just simply traverse this whole array and see which number is missing. And traversal takes order of n. So this is the time complexity for this particular method, and the space complexity is of order of 1 because no extra space has been taken, or constant extra space has been taken. So this is a better approach, if you compare it with the first, but it is still not a good approach. Now what we can do is that in order to save our time, what we can do is we can just compromise over the space. So as we know that the numbers are from 1 to 8, what we can do is we can just make another array which is of 8 size. And so we'll just traverse on this particular array and we'll mark those indexes true. So let's suppose I'll just make an array 1, 2, 3, 4, 5, 6, 7 and 8. So we have this array of size n plus 1. So or what you can do is you can also keep it of size n and you can map 1 to 0 and 2 to 1 and so on. Or you can also make it the size of n plus 1 and just do the mappings over here. So what we'll do over here is, so first we get a 2. So I'm going to go to 2 and I'm going to make it true. That this means that I have found this particular number. Then I go to 3, I make it true. Then I go to, this is 5, I make it true. Then we have 8, we make 8 as true. Then we have 7, we make 7 true. Then 6 becomes true and 1 becomes true. Now after doing this, I am just going to traverse from 1 and I am going to see where true is not present, that is where false is there. So the number which has false is that number which is our answer. So this takes the time of n plus n. One n is in order to mark the numbers and other is to find, and the space complexity is of order of n because we are taking an extra space for the same. Now next what we can do is, now see over here in this approach we know that the numbers are from 1 to n and what we can do is we can use the property of summation. Now what we can do is that I am just going to sum all of these. So if we have numbers till 8, so I'm just going to take a variable sum or any variable, and I'm going to store a summation for the same. Now if I subtract the numbers given to us from this summation, so the number which is missing won't get subtracted and will be stored in this particular variable at the end. Now see, the numbers in, now suppose the array was 2, 3, 5, 6, 7, 8 and 1. So I'm just going to traverse this array and subtract these numbers from this sum. So first I'll subtract 2. So 2 gets subtracted, then I subtract 3, then 5, then 6, 7, 8 and then 1. So at the end, the number in sum is 4, which is our actual answer. Now this approach takes time of order of n and a space complexity of order of 1, but there is a drawback to this method. Now what happens over here is, now suppose we have a lot of numbers, and when you do the summation for the same, so what can happen is that the range, the number or the summation can exceed the integer range, and hence there will be a scenario when you get a wrong answer. So you can use this approach, but it might work. It might not work with certain constraints if there are any in the question. You can just find the summation with a simple formula n into n plus 1 by 2, and just then traverse this array and just subtract these numbers from this summation, and you'll get the answer. Now we can just modify this method a little in order to get our answer. Now what we can do is that, now see, in this method, first we were adding all of the numbers and then we were subtracting these numbers. So the problem which was coming was because of this summation, because we were adding up a lot of numbers, all of them together, and this might result in the exceeding the integer range. So what we can do is, instead of summing them up together and then subtracting the given numbers at the same time, we can do this simultaneously. Now what I mean is, now let's suppose our array is this. So over here the missing number is 6, and now what I'm going to do is I'm going to keep sum as 1, and I have a counter which will give me the numbers from 1 to n. So simultaneously, first I'm going to add the first number and I'm going to subtract this first element. Then I'm going to increment it, and now this will be incremented to 2 and the pointer will point to 3. So I'm going to add 2 and I'm going to subtract 3. So instead of just adding them up together and then subtracting these numbers from it, I'm doing it simultaneously. I'm adding one number and I'm subtracting one. I'm adding one and I'm subtracting one. Now what this will do, it will help you balance a little and give your answer, but this might also not work in certain conditions. So you have to first see what the conditions are, and accordingly you have to use an approach. Now this goes to 3 and you point over here, so you have plus 3 minus 8, then this becomes 4, then you have plus 4 minus 7, then this becomes 5, you have plus 5 minus 4, then plus 6 minus 1, plus 7 minus 5, and at the end, as you know, the count will go to n, and this is only n minus 1, we will have plus 8. Now once you solve this, so 2 gets cancelled with 2, 3 with 3, 4 with 4, 6, 6 doesn't get cancelled because this is the number, 1 with 1, 7 with 7, and 8 with 8, and 5 with 5. So 6 is our number. So this is a better approach in comparison to above approaches. Now let's talk about the main approach, which is the most efficient so far. So before getting to know about that approach, you need to know some few properties. Now we are going to use bit manipulation in this approach, and you need to know that if you do XOR of 2 bits which are same, so the answer comes out to be 0. And if you XOR anything with 0, the answer is that thing itself. So if I just draw the XOR table for you guys, so it looks like this. 0 and 0 becomes 0 because they both are same. Then 0 and 1 using this property becomes 1. 1 and 0 using this again becomes 1, and 1 and 1 using the first one becomes 0. So just remember this thing, and now we are going to apply this to a question. Now see, what we're going to do is I'm just going to take any variable, suppose target. I'll just take it, and I'm going to XOR all the numbers from 1 to n. That is, I'm going to do 1 XOR 2, this is the XOR symbol, XOR 3, 4, 5, 6, 7 and 8. Okay. Now we have these numbers. Now I'm going to XOR the numbers given to us. Now just see what I'm doing. Then you will get to know what is happening within. Now suppose now these were the numbers given to us, in which the missing was 6. So we'll do XOR 2, XOR 4, XOR 5, XOR 6, XOR 7, XOR 8. Okay, now let's now over here just assume that number 3 is missing. So we have 2, 4, 5, 6, 7, 8 and 1. Now see, 1 and 1 are same. So they become 0. 2 and 2 are same. This becomes 0. 3 is, now let's just skip 3. Now we have 4 and 4 are same. They become 0. Similarly, you have for 5. They become 0. For 6, 7 and 8 as well. So 6, 7, 8, and at the end you have number 3. So now let's just see how this is going to turn out. Now 0, 0 is 0, these two 0, then even these two become 0. These two are 0 and 0 XOR 3 is 3. Now 0 XOR 0 is 0, 0 XOR 3 is 3, and 0 XOR 3 is 3. Now what happens over here is that first when we had XORed the numbers from 1 to 8, these numbers are the numbers which are already present in the array are removed. So when we had these numbers, that is from 1, 2, 3, 4, 5, 6, 7 and 8, as I XOR 2 with this number, so this gets eliminated and we have 1 XOR 3, 4, 5, 6 and 7, 8. Then we eliminate 1, then we eliminate 4, 5, 6, 7 and 8 because these numbers were present in the array. Only number 3 was not in the array, and hence this didn't get removed from this target, and hence this number 3 is present in the target once you XOR all the given numbers to you. So this is an approach which is really fast, and you can use this approach in almost every constraint. So it takes a time of order of n and a space of order of 1. So these were various methods, a total of 6 methods using which you can solve this particular question. This question has been asked in various companies. And this was all for today's video. If you like my video, then do subscribe to my channel and go follow me on Instagram, and also you can get all the codes on my GitHub handle. I leave all the necessary links in the description box. Thank you.